We have a panel of discussants. They have the opportunity to ask speakers questions, and they also have the opportunity to say a few things if they would like. And since I am one of the co-organizers, I'm going to use my power to ask one of the first questions. And that photo was snapped last night from Don's talk, and I've titled it Don's Phylogeny. So, Bernard Wood. Of course. What do you think of Don's?
Well, okay, I'm not sure what the question is, as Kay has just whispered in my ear. But I think the problem is that one of the things that the molecular revolution has done is that it has demonstrated, not just in primates, but in almost every group, that if you try and reconstruct relationships on the basis of morphology, there are so many examples where the molecular evidence for the relationships runs counter to the morphological evidence. And my sense is that there is no reason to think that the hominin clade is somehow immune from what's called homoplasy, which is where shared morphology doesn't necessarily mean close relationships. It just means that that morphology happened to be good for that particular challenge, and so that morphology pops up in different branches of a tree. I'm probably more convinced than most of my colleagues who are maybe in this room and outside of this room that what's called homoplasy is something that makes reconstructing phylogeny difficult. And so therefore, as a cautious ex-surgeon, I am very reluctant. And what sort of people call a woodogram, which are these sort of diagrams that have sort of columns on, you know, the first thing I say to people is, what's missing? And they say, oh, you know, you're missing a column or something. I said, you know, what's missing are any lines, okay? And that's deliberate. And so I'm not going to rise to the challenge of, I mean, I think, I think Anamensis is probably ancestral to Afarensis. I think that's, I think I would put at least sort of $10 on that. I would put probably $12 on Paranthropus ethiopicus being ancestral to Paranthropus boisei. But other than that, I'm not going to waste my money.
Anne would like to follow up.
I just want to follow up on that. So my editors always ask me, they don't really care about Paranthropus. They just want to know what's ancestral to Homo. And I try to always tell them, Paranthropus is really interesting, right? We really care about these other creatures. These are the, the Ministry of Funny Walks and odd people, menagerie of characters in our human family tree. If we don't have a tree anymore, right? Or if we have a very simple, weird, I don't know what you call it, how do you communicate relationships?
Is that on? Okay, okay. Well, you just gave me a dud microphone. So I make, the contrast between what I know about my family and what we know about hominin evolution. And everybody makes fun of me because I sort of keep talking about motor cars as an analogy for hominins, but I talk about my family and I show two pictures. I show the picture of my great-grandparents' golden wedding, and I show the picture of my christening, in which I have a starring role. And in both those instances, I know who were my direct ancestors and who were my close relatives. And I know that, there is good evidence. We don't have that sort of evidence for hominin evolution. And it's difficult to explain to people that paleoanthropology is a branch of paleontology. And Bob Martin used to say that there are hard sciences and there are soft sciences, and then there are the difficult sciences. And paleontology is a difficult science because you're trying to answer questions which are perfectly legitimate, but it's very difficult to explain to people that you can't always answer questions because they're interesting. You need to be able to answer a question when you have enough evidence to answer it, even though the question is extremely interesting and tantalizing, and sometimes you are tempted to provide answers which are probably not reliable. And to go back to my career as a surgeon, I wanted to do things that I could rely on. I'm not interested in a phylogeny that only works on Mondays when the temperature is between 75 and 93. I'm interested in a phylogeny that works on Mondays, Tuesdays, Wednesdays, Thursdays, Fridays, Saturdays, and Sundays, and in all weathers. And so until I can get that sort of reliability, I just don't think it's fair to get people to think that this evidence is more reliable than it really is. Does that mean the evidence is uninteresting? No, of course it isn't. But we're not doing art history here, where there is a lot of evidence about who painted what. But that doesn't mean that there is still doubt about whether this picture was painted by somebody or not.
You would like to say something. I'm going to come to you in a second. But one thing, Bernard, I would say is that all statements in science are probability statements, right? And you started saying, oh, I'd put $10 on that, and those are probability statements, right? So you were getting there. But we heard two very different views of the approach to paleoanthropology at the beginning of the conference, one by Bernard and another by Ian. What do you think of what we've been saying?
It's on? Yeah. Okay, well, what I would first say is that paleontologists in other areas of paleontology have developed numerous quantitative methods for approaching probabilities and for reconstructing phylogenies using molecules, using morphology, synthesizing all the various areas of information that are available. And paleoanthropologists have been very slow to capitalize on this kind of thing. And one of the reasons for being slow about it is what we are dealing with here is an incredibly closely related group of forms. And when you have a closely related group of forms, the differences that you're going to have to deal with are going to be very small ones. And then they're going to be inordinately affected maybe by homoplasy or parallelism, whatever you're going to be, whatever word you wish to apply to it. So the methodologies are out there, but they're very hard to apply to paleoanthropology. And that's one reason why paleoanthropologists, I think, have been slow to jump on this particular bandwagon. But it's also because we have still this Marean linear mindset. That is a very linear diagram when you come to think of it. You know, it's got a couple of forks, but mainly it's the lines that are connecting ancestors and descendants. And proving ancestry and descent is extremely difficult. You can prove relationship. You can objectively, in principle anyway, demonstrate relationship among taxa. In terms of a sister relationship of descent from a common ancestor. That part is relatively easy. What you cannot demonstrate is ancestry and descent, because the ancestor is going to have to be primitive relative to the presumed descendants in all characteristics. And if the ancestor is primitive in all characteristics, there are no derived characteristics to link the ancestor and the descendant. So you have these problems. But there are people out there who are developing methodologies which I think paleoanthropologists could use, and it would be really good if they would take advantage of this.
This little button is hard to turn. You know, I do this for communication to the average person who's sitting in the audience. And I agree very much with Bernard, but we just don't have molecules from these fossils, okay? Like the people who have redefined the systematics of birds, for example, living birds. So you know, those are things we just simply can't use. So I use that as a device to portray time and purported relationships in a very simplistic way. Okay, and I agree with Ian also, but just to repeat what Ian has written so much about, we're probably always going to underestimate the numbers of species, because I think Bernard has the same view, that it's not just simply the hard anatomy that changes over time. It's other things that don't preserve, like skin and hair and so on, mating patterns and so forth. But at least it gives an impression to a average audience of you know, non-specialists, that we have a heuristic device here that helps us kind of at least establish broadly relationships between the robusts and the non-robusts and so on. And I know that Bernard is very secure about his own family relationships, and as far as I know, I don't have any other children. So maybe I'm not quite as sure about my family relationship. But drawing family trees is a way of establishing relationships in the minds of people who come to this as the average person. And we can spend all day talking about these things. Although, you know, when in the mid-1980s, when we made predictions that there was a connection between afarensis and other species, we're beginning to fill in some of those gaps. And there are lots of things missing. I mean, we don't say anything about platyops in this, for example, Kenyanthropus, and other species. I didn't talk about predecessor for Anamensis, for example. But this is just, for me, a way of communicating how I sense the diversity in Pleistocene hominins.
Actually wondering if Andra can maybe talk about that a little bit. So think about taxonomy and phylogeny.
Right, so very complicated question. I think, so what is important is to communicate what these trees, what these graphs are actually communicating. So if we treat them as hypotheses that we put on the table for other people to test, well, this has a generative role of knowledge in science. Sometimes it's good to put hypotheses out there for people to test them. This will drive more, more research to understand the robustness of the hypotheses that have been formulated. I think the problem is miscommunicating what these phylogenies are. So attributing to them an epistemic status that don't have. I think it's a matter of understanding, yes, what these phylogenies represent.
Okay. Sorry? Okay, yeah, we're going to come to questions. Do any of the discussants have some comment?
I have a question for primarily Zerai, but then also a little bit for Carol and trying to rope in Yohannes too. So Zerai, for the Dakika baby, you showed a lot of morphological evidence for arboreal adaptations, and your explanation was sort of that, well, chimps and other apes the juveniles spend a lot of time climbing. That was before the Bertelli foot was found, which is obviously not very far away, and I know you guys have your opinions on whether Bertelli is de remita and de remita is afarensis or whatever it may be. But what would you say if someone did a $10 or $12 bet suggesting that Salam is perhaps a Bertelli-ish infant or whatever Bertelli may be? What would be the possibility, or is there a possibility that Salam, with its climbing adaptations, is actually more closely related to whatever the Bertelli foot represents than afarensis, the Bertelli foot?
Okay.
With its climbing adaptations than with the afarensis trajectory of adults.
Okay. Yeah, it's clear. Thank you. But maybe I will quickly comment on the previous question, if that's okay, Curtis. Is that okay? Can you hear me? Yes. Yeah, so I think I completely agree with Bernard on the rampant nature of homoplasy and how cautious we should be, especially when we propose something like this. But at the same time, when I think of what I think of science in general, which for me is not a matter of finding the truth, but approximating the truth. I think the truth and science have a asymptotic relationship. So I'm not after the truth. I am trying to go to the truth. So that asymptotic relationship between science and truth must be underscored. Meaning, when I see a phylogeny like this, what I see is, like Andrea said, it's a hypothesis. So what are the best tools to test? So then the process of testing the phylogeny becomes more exciting than finding the truth. That's what I would say on the first one. On your question, Chris, what Salam did is it added the number of primitive characters to already known many primitive characters in Lucy and other adult individuals. So, but what is interesting now is trabecular anatomy, character plasticity, and other approaches can allow you to look into the biomechanics of that so-called primitive trait. So whether that trait is primitive or derived in a sense of chimp versus human, what matters is what is it being used for? That is a question. So given that, therefore, if indeed Salam and Lucy and others are climbing, would they be a member of the Bertelli family, whatever the name is? I think it's a distinct species. No, because what you see in terms of the foot in the Dakika child is the children in Australopithecus afarensis have more mobile toe as they grow older. However, it becomes more aligned with the other. So the point, therefore, is the information that comes from Salam is not really new. The features, the primitive features, existed already in afarensis. So the Bertelle foot is completely unique. That's why I sometimes joke with Yohannes, why don't you mix it with Diaromeda and name a new species or a genus? Because it may represent a different adaptive plateau, given the combination of the Ramidus-like foot and the afarensis-like cranium or jaws. So yes, what Salam does is basically reinforce what we know, but work like what Tracy Kivel does using trabecular anatomy, the scapula, the semicircular canal, however, suggests that they were climbing, which does not mean they were Bertelle-like. So that there are two different things. I hope it's clear.
I've been tasked with weighing in. So I've been thinking a lot before speaking to Bertelle, the issue of the climbing primitive ape-like traits in afarensis. As I mentioned, there are really different schools of thought. You have the sort of primitive features are always in any fossil animal, any living animal, very difficult to understand. If something we know is recently changed from an ancestor, we can see morphological change in a direction. We can pretty clearly infer that there was selection for whatever that trait had to do with, and that's easy. What's really hard is when there's a primitive feature that's hanging on, to know whether it was retained for a reason, or if it just happened to still be there and selection hasn't bothered to get rid of it, is just fundamentally difficult to understand. And very clearly, we know that there was strong directional selection for effective terrestrial bipedal locomotion. That's easy and done and said and no problem. The trick is to figure out what these primitive features can do. And Zarai's comment about plasticity is really important because we can ask different questions of the fossils. What were they adapted to do? What had selection shaped them to be able to do? And then if you got in your time machine and went back in time and watched them, as you put your primatology hat on, what would you see them doing? Would you see them in the trees? Would you see them on the ground? Would you see them whatever else it might happen to be? And that's trickier, but if we can identify traits that are plastic, bone's a dynamic tissue, and it's shaped by activity. And if we can determine the parameters of exactly how that works, then we can say, this shape would be influenced by this behavior or that behavior. Those sciences are going on vigorously. They're very complicated. For example, people use mouse models, and you can have mice and you can have one group exercise and another group exercise. You can look at changes in bone shape. Well, you might take a different lineage of mice and we see them respond in different ways. There are things like stem cell reactivity in the marrow spaces that influence these responses, things that I don't even really understand very well. So there's going to be a lot of information there. We're learning more and more about, for example, how the spongy bone inside the trabecular bone might be influenced by activity, by other bone shape influenced by activity. And that's where we're going to be able to answer the questions about what did they do versus what they were designed to do. I was educated in the tradition of they weren't climbing. That's sort of my ontogeny, if you will. So, but I recognize that the features are there, and I think it's really important to figure out how important these were for these animals. And it's always going to be difficult, but I think the answer is going to be looking at plasticity and looking at other animals and how do things work. I think it's also really exciting that we're in a time in science where we can start to apply new technologies. We can start to image, for example, soft tissues, muscles and nerves and bones that are muscles and nerves and other soft tissues that may exert forces or influences on that bone during development. We're beginning to be able to see those kinds of things in modern animals, and we're hoping to bring those back to the fossils. So I think that the debate, as I said, isn't solved. I don't know what's going to be solved when we come back for Lucy's 75th or not, but I think we're going to have a lot more information, and I think plasticity is a really important place to look, and I think bringing in new perspectives and technologies to address these questions is going to be where it's at. And yes, Zerai and I have disagreed about some things, but we're still really good friends, right? Yes.
All right, I think when I think about Selam, the fact that she is juvenile, it makes me think about, like, do we really understand growth and development in any of these fossil species, right? So Selam is assigned to Australopithecus afarensis, right? But she was juvenile. But we do have adults of Australopithecus afarensis. One example is we have a 3.6 million year old partial skeleton of Australopithecus afarensis, nicknamed Kadanumo, from Oranzomille. Now, one of the key traits that one can highlight in terms of the locomotor adaptation of individuals like Selam, a kid, was the shape of the scapula. That was one of the arguments that was presented, and that glenoid fossa, which is like the joint, faces kind of superiorly. Now, you could argue that this is arboreal adaptation, but what we need to ask is, was that kid gonna grow maintaining that morphology, or is it gonna evolve into something that we see in individuals like Kadanumo? It's an adult individual, it's a complete scapula. We can clearly see that that joint is not facing superiorly. It's facing laterally, and the spinous process is also horizontal. All of these are what we see in, like, modern humans. So I think there could be a lot of variation too, right? But the key thing is understanding the growth and development. I think one of the major significance of Selam is it gives us some idea in terms of what this juvenile Australopithecus afarensis looked like. But at the same time, we can't deny that as they grow, because we've seen it in a lot of primates and other animals, as they grow, there are morphological features that change, right? So we have to really consider that as well. So I think, talk about Burtele foot. It's an adult individual, right? But no paleoanthropologist will actually argue with you that it belongs to Australopithecus afarensis, because it's not. Afarensis didn't have opposable big toe. And Bernard clearly puts it, like, in high confidence as different from Australopithecus afarensis. And I asked him yesterday, can you put Australopithecus deiremida in high confidence? And he wanted me to bribe him. He said, you give me one of the Ethiopian baskets, which I'm not going to do. But clearly, that adult individual, the Burtele foot, it's really difficult to argue that it actually belonged to Australopithecus afarensis. So that also brings me to Andra's lecture, talk on one of her slides, where she mentioned, like, small sample size is always a problem. Yes, we all agree. But sometimes single specimens can also be really significant, and the Burtele foot is one example, right? But obviously, we didn't put it into anything because there was no, because traditionally we're always reliant on, like, teeth, jaws, and crania when we name species. But that Burtele foot, unfortunately, didn't have anything clearly associated with it that is, like, dental or cranial that we can make, like, inferences about taxonomy. But morphologically, it's definitely different from Australopithecus afarensis.
But you couldn't morph a Dakika baby foot into a Burtele foot, could you? Speaking of plasticity.
If it grew, because that was actually my sort of question. It's I think it's related, which is, how sure are all of you who do this, that now that there's multiple species in the afar, at the same time, that Dakika isn't one of those other ones?
I think I can answer that. Forgetting the fact that at the first family locality, there is an infant cranium at about the same age of death. And I haven't studied it as intensely as Zerai has, but we are all in agreement that the collection at 333 is a death that's, you know, a catastrophic assemblage of some kind, that it wasn't accumulating over millions of years, or it wasn't accumulating over hundreds of years, that it was something that happened instantaneously. We don't know how or why they died, and Kay was reluctant to talk about that. We need to move forward on that. But there is a baby there that, to me, looks identical to the Dakika cranium.
So yeah, the specimen he's referring to, that's AL333105, but also there are 2 other juveniles from that site, and many mandibles of the same age, and they're a dead ringer. It's exactly a replica of what you see in Dakika. The only minor difference that you see between Dakika and 105 is the subnasal region is slightly more prognatic in 105. Could be sexual dimorphism, a bit small male or something, but otherwise it's a replica. So our attribution of the Dakika fossil to afferences is based on the morphological similarities to the juveniles of afferences that already have been published for a long time, and clearly different from the tongue child. Now, do we know the juveniles of Kenyanthropus or Australopithecus platyops? We don't have that really, as far as I know. What else do we have? Of course, the Bertelli foot clearly is, for me, a different species. I agree with Yohannes, but we don't have the craniodental material. Yeah, so it's pretty secure in terms of attributing the Dakika child to afferences.
I can echo that too, especially looking at jaws. The features that are distinctive about afferensis and the adults, at least in the jaws and so forth, are also found in the juveniles, and it's all very secure. But if I could sort of, you know, we're talking about the sort of levels of uncertainty and hypotheses, and I have a question for you, Anne, that sort of goes back to the question that you had asked. We have a lot of public mistrust of science, and people hate it. You know, look at the COVID pandemic. Well, the scientists said this, and now they're saying this, and now they're saying this. And people who study human evolution get this all the time. Well, you said this was the ancestor, and there was one species, but now it's another species. And as scientists, we understand that what we say are hypotheses, and they're subject to change, and that's the beauty of science and all of that. So, you know, going back to the original question, too, with the phylogeny, it is important for people to have things that they can understand. So that's important, but it's also a hypothesis that may be subject to change when Yohannes finds yet another specimen at Rwenzori or what have you. So as a journalist who's charged with communicating science to the public, how do you strike the balance between sort of the uncertainty and the hypothesis, you know, continuous generation of hypotheses with this, and communicate to the public that that's how it should be and they should learn to be comfortable with that, versus giving them the facts that they want to grab and hold on to and know? And I don't know if you have an answer to that, but you have anybody in this room, I hope, I'm sure has thought about it more than any of the rest of us.
Well, I just had a good talk with Kim Hill about this yesterday, about communicating science and stories, and we sort of concluded that the narrative is important, getting people's idea and the general ideas of evolution, how evolution works. You want to get that out there and get that right, but maybe all the complexity and details aren't as important. Now this, I hate to say that because I really pride myself on getting things right. And the nuance is really interesting and really important, right? For example, one of the things I keep thinking about, and this is a question I had for you, is as we see more species and more complex speciation at all different levels of the human family tree, that takes away the notion of human exceptionalism, right? And when I talk to John Matani, we see in apes and other species more complex, you know, that you see different you see us acting more like animals, right? When you get this new picture, there's more diversity. We're interacting with, where hybridization's happening all the time. There are different things going on, perhaps, right? That's what seems to be implied by all this. And yet, look at us now. So I'm trying to think right now how I reconcile the uniqueness about humans. Is this just recent? You know, are the others unique too? You know, how do we think about this? Because I love communicating the notion that we're acting like animals. We're evolving like other animals. Evolution has some consistent rules, right? And that there are many more species. So I guess I'm not really answering your question, Carol, because communicating complexity is the challenge. And the truth, what we have to do is true, but we're only talking in metaphors. That's what language is. It's always a reduction of reality. You know, we're always a step back. So I don't know. I'm not really answering your question. Maybe somebody else can get to
I just want to, I'm going to interject. We should transition to questions from the audience. And I know there were some coming from back there. And as I'm walking back, I will, okay. Can Kim, two things that are short, right?
Two things that are short. I think the fact that there are so many species and there's going to be more tells us that when I was talking about a low probability evolutionary transition followed by another low probability, followed by another low probability, so that when you get to the real end where you get this incredible human uniqueness, the evidence, that evidence is not there for half the stuff up on the chart there. So what I'm going to say is that the fact that so many of those don't go there is really telling us that those are low probability steps, that all those other ones off to the side didn't go through some of the low probability sequence, and it's a very, very unique pathway to get to the very end where you can send a man to the moon, let's say. You know, the robust Australopithecines didn't send somebody to the moon because they were lacking in a couple of the end steps. So that's why I was saying if this is a 1 in 100 times a 1 in 100 times a 1 in 100 and you have to go through 5 or 6 steps to get to the end, it's not going to be surprising to have a whole bunch of other branch stuff that doesn't quite make it there and isn't as spectacular. And then the other thing I was going to say about human uniqueness is I could back off and talk about hominin uniqueness, and I would say hominins are really unique in some ways, and the big question is why aren't there other taxa that are non-hominin that are, you know, doing similar things to the hominins? Because, yeah, I mean, a lot of people are going to guess that part of why we end up with only one species, and there may have been 20, is has to do with stuff that has to do with competition. Ultimately, that's a piece of the picture. Is that
If there were endless time, I'd love to get John Matani's take on that.
So historically, paleoanthropologists haven't always wanted to hear from the geneticist in the room. And as a geneticist in the room, and this was really a comment toward Don's phylogeny here, and I agree with the statements about, you know, phylogenies being hypotheses about relationships, but I think one thing that's been so cool about both, you know, the recent studies in, of course, with ancient DNA and also in other primates is really the importance of hybridization and integration. And I think if you look at so many species, existing species or whatever groups living at the same time, that has to be part of the equation there. I think another thing that's going to be really interesting in the next couple of years is the proteomic data. We already have some from a Australopithecine or Paranthropus, I guess, and there's more in the works. So I think that will be, it's a very limited form of molecular data, but that'll be really interesting to throw into the mix.
I'm sorry. Proteins can help you sort out different genuses, right? Not necessarily species.
No, you could potentially do species. You can figure out the sex of individuals.
I knew sexing, right.
Right. So it
Maybe
depends on
diet.
how many proteins they can get. They're basically getting the amino acid sequence, and from that they can infer minimally a portion of the DNA sequence. And so if they have enough, they can look at broader relationships.
I'm not going to rise to Anne's challenge, but I want to ask a question. It's a historical question that actually arises from Anne's lovely piece yesterday. A quote by Tim, and also because of my own background, educational background. In Anne's article, Tim White said something to the fact that Lucy arrived on the stage when the great paleoanthropological question was, how old was the hominin line? I think it's fair to say at the time of Lucy's announcement that most paleoanthropologists thought that the last common ancestor was way back in time, not perhaps back all the way to Don Man and the Oligocene, but are the opinion still buying into Ramapithecus that 15, 20 million years ago. I was educated at Berkeley, early 70s, mid 70s, where I was being taught a very different story by Vince Sarich and Alan Wilson, who were arguing quite forcefully that our lineage is not that old. So I remember as a student reading the announcement of Afarensis and thinking, my God, an Australopith over 3 million years ago, looking sort of chimpy in the head, primitive characteristics, and thinking to myself, that seems to fit with the Berkeley line at the time. So my question, I guess, is more for Don than anybody here. Don, did that discovery, or I don't know, haven't known you that long. What were you thinking about that central question at the time, and did Lucy actually influence your thinking on the matter? I'm sorry. Don, did Lucy change your mind about this question about how old the hominin line is? How old, when did we split off from chimps and gorillas and bonobos? No. Well, that's simple.
The discovery of Lucy didn't change my mind about how old the hominid lineage was, because there were at that time a few fragments of fossils, like from Lothegum and Canopoi and Baringo, that were older. And I also subscribe to the view that the first appearance of something is not necessarily the oldest appearance. And looking at the little diversity there was after more recently, within the South African and East African hominins, there had to have been ancestors to that. So it didn't really change my mind. It provided the evidence.
Maybe I'll ask to contextualize your no answer. What was your position at the time of the discovery of Lucy?
Well,
into a late or early divergence?
Well, the perception was that Africanus was the ancestor to the later lineages. Right?
How old is what was your thinking about how old was the hominin line? When did we diverge from Africa?
Oh, when did we diverge from the, I see. Yeah, all right, well, yeah, finding, well, my view was that it was somewhere between 6 and 8 million years ago.
Okay, well, that answers my question.
Yeah.
Do we have other questions from the audience? Okay, Jess.
Of course I have a question. I have a question for the audience. What are the interesting questions to the people in this room? Like collectively, what do you want to know? Is it these relationships that dominate your curiosity, or is it more questions of behavior and day-to-day life? Is it familial relationships and ecology? Is it adaptation? You know, what are the things that are really interesting to the people who we want to communicate this to? That's something that is maybe a good question for you because you must talk to a lot of people, but I'm curious about, I know it from the student perspective, but this is a different group, and I would love to get some feedback.
But diet is a big one. People want these creatures to come alive. What do they eat? How do they live? How do they mate? What were their family groups like? I mean, any research that bears on any of that is really interesting, right? What kind of world did they live in? Did climate change affect them? Did they respond to that? Those are, what caused natural selection to favor some adaptations other than others? And what does that mean for today? Right?
That's
what
where
does
I'd
it
like
mean
to
for
go.
today? Always,
That's where I'd like
always,
to
always.
go. It's a great question. And I think the question that the lay public has is the hardest one to answer and may not be possible to answer tightly connected to the pure science. So it may get to a conjecture that scientists are understandably reluctant to go to. But perhaps it could be summarized as, what are the lessons that we've learned from the past? What do we know or think we know about the human career that would help us to make better decisions for the future?
I think the problem is a mix of scales, because what we can get from the fossil record is very long, deep, and the decisions that we have to make next week about ameliorating climate change are on a completely different order of scale. And so this probably won't be popular with my colleagues, and it certainly wasn't popular with Richard, is that I think human evolution has very little to tell us about how we can survive. And that's maybe not popular, but I think looking at all of this is not very helpful to how you solve violence in the Near East or Middle East. It's not very helpful to how you try and persuade people to behave differently in their lives, to try and consume less oxygen or more carbon dioxide or whatever it is. I just don't think these things are similar enough.
Can you hear me? Yes. So I'm most interested in cognitive evolution. I'm most interested in cognitive evolution. Kim's talk about the social brain, cooperation, and its relevance for the future. Kim, I think on one of your slides you had TOM, theory of mind. How we evolved, something like that, which leads to empathy, understanding each other or not, and what's happening with the evolution of that.
Say one quick thing, because I didn't have time to say this in my talk when I was talking about the evolution of spectacular prosociality. And some of my friends in evolutionary economics have called it, the most spectacular anomaly that they didn't expect to find. I'll give this example because I still think that there's lots of things. This is going to get us a little bit into evolutionary psychology, that we can understand about the real truth of our adaptive design. I think that humans are the only species on planet Earth of the 9 million eukaryotes who can walk down the street, see a sign from a homeless person saying, I lost my job, take out a $20 bill, stick it in their bucket, walk away knowing that first, they're not related, second, I'll never see them again, and get a wonderful feeling from it. I don't think there's a single other species on all of planet Earth that would get a wonderful feeling from giving up resources to an unrelated individual who will never be seen again. And the fact that we have that biochemical design, which comes from cooperative tendencies and proclivities over long periods of time, is the kind of thing I do think we can learn from human evolution to start understanding solutions to modern problems. So I do think there's some relevance.
Jessica, I would say this, as just a layperson, I don't know much about this stuff, so I'm just, my view is the race is on, is how the public looks at things. The brain versus upright walking. Kim's talking about carrying things, weapons. Which is first? Carrying things, weapons? Is it the brain? Whose brain is first? And now people are coming out of Africa. From where? South Africa? Morocco? Who's getting there first? Did the Denisovans get there first? What happened? Did the Denisovans lead to us? Did the Neanderthals? And if neither one did, how are they connected to each other? And so it's always a race that I think the public's interested in. How fast did the brain grow? And when we find out Lucy didn't have the brain, when did the brain start? Where did the brain go? And we're missing all those fossils, aren't we? I mean, those 2 million, 1.5 million-year-old fossils is the brain growing? How does it grow? And how does that brain growth relate to what Kim was talking about? Their ability to use the tools, carry the tools, figure out how to work together, and what's that pace? I think that race is what intrigues the public.
Also a layperson. My career has been as a restaurateur, but I've always been fascinated with evolution, human evolution. Is that better? Oh, gotcha. Okay. So a question I would have is something that doesn't fossilize, but just as where did intelligence come from? My question would be, when would does anyone have any thoughts, or is this even discussed much in the high-end world of human evolution, where the mating system, which would have had to have changed from a multi-male system to a pair bonding system, what would have ever caused that to happen? Anyone have any thoughts on that? Somewhere along the line, like when and why did it happen? Well, how did Lucy mate? Was that a pair bonding situation, or how about Homo erectus? Somewhere along the line it switched.
Just really quickly.
Yeah, that's one of the biggest questions in paleoanthropology, because we understand how significant it is. We don't have an answer. We have a lot of theory, but we don't have an answer as to where that pair bonding, when and where that pair bonding first happened.
But I do think we have good biological reason to believe that we've got hypotheses that are likely to be correct by, first of all, looking at other species that are pair bonded. A huge fraction of birds are monogamous and pair bonded, and we pretty much know that the reason is because the nestlings require enough input that mom can't do it alone, and male birds, if they weren't bringing back resources and provisioning, would never leave any descendants. So all of the psychology and emotions and so on, the feedback that makes males want to do paternal investment, evolves in birds. I showed data suggesting that human juveniles, when we moved into a new adaptive feeding niche that required high levels of skill and learning, and you would get peak foraging return rates in the 40s and 50s, and juveniles produce nothing, the juveniles are totally dependent. I'm suggesting that female hominins could not raise surviving juveniles if they didn't get paternal investment, and the males who had the proclivity to want to do paternal investment were the ones who left descendants, and over time, males got into a psychology where they wanted to be. Because chimpanzee juveniles are totally economically dependent when they're 2 years old. whereas humans aren't until they're 15 years old because of the feeding niche. When you look at what happens with extractive resources in hunting, you simply can't do it. One of the things we discovered with hunting that I didn't have time to go into is that peak hunting return rates in hunter-gatherers peak in the mid-40s, like 45, 47 years old. But strength peaks at age 22. There's a hell of a lot more to being a successful hunter than strength. And what is that? It's all up here. And juveniles don't have it. It takes 20 or 30 years of learning before they understand animal behavior and tracking and what the wind means and this and that. So the skill-based, what I call human capital-based economic niche means juveniles just simply can't produce. And older individuals can produce, and they become the provisioners of juveniles. And as I mentioned, when juveniles are so expensive that females can't do it alone, the males who become paternal investing males are the only ones that leave descendants, and that tendency evolves over natural selection. And voila, we get another monogamous pair-bonded species, just like all the birds that have the same explanation for why they're monogamous and pair-bonded. So I think we have a really good understanding of why humans became pair-bonded monogamous primates, unlike chimps. But it all goes back to the feeding niche and the fact that we moved into a feeding niche where juveniles couldn't do it because it's learning intensive. It takes years and years and years before you can really produce energy the way the older adults do.
Okay, so we have one question over here. So why don't you go ahead?
Thank you. I have a particular interest in, so when we're looking at the phylogeny and you have a new fossil and you're trying to decide genus, species, where does it fit? How often are abnormalities, like different mutations of already existing species and those that are already showing up there on the screen, like how often is that taken into consideration? I'm thinking back to, like, I believe it's Darwin, like around that time, they had found the Neanderthals and they had said something to the effect of, oh, no, those are just, people like me and you, they had rickets. So how often are those types of discussions had when you're trying to figure out this lineage?
Bernard, did you want to respond?
Too often, because when people were thinking about Homo floresiensis, you would have thought they would have learned from the Neanderthals that to invoke a pathology was a bad idea. But, as much as I admire Kim's confidence in our biology, we don't learn from history. And so the people who were looking at Homo floresiensis, wow, it's pathological. It's got some sort of, they've got, these things are as rare as hen's teeth. And so it's sort of crazy to use that explanation. But to go back to Don's phylogeny, my concern with those things is that if you do the thought experiment that say, the average hominin species lasts for 1 million years. The average hominin species has a range of, a couple of thousand miles this way and a couple of thousand miles that way. So you have 1 million years where the species can vary according to the different habitats that it is occupying within its range, and then sort of stuff happens. There is just sort of chance events, and so The point is, it's not whether this group of fossils is different from this group of fossils. The question is, could these two groups of fossils possibly be sampled from the population that I've just sort of sketched out? 1 million years of time and a large amount of range, and climate differences across the range, so they're smaller here and larger there. There are dietary differences across the range, so the ones over here tend to eat more tough things, and the ones over here don't have to eat more tough things. And so the question is not whether my group of fossils is different from your group of fossils. The question is whether my group of fossils and your group of fossils could all have been sampled from the same population. And the problem is that using individual specimens, especially well-preserved specimens, as the icons of species, there is no evidence, as far as I know, that the best preserved specimens lie on top of the bell curve. The best preserved specimens might lie one end of the bell curve. And so the difficulty is trying to represent to the public what we are really trying to do, whereas sort of diagrams like that, which I've used, and I'm being as critical of myself as I am of anybody else, how we sort of make it clear what we're really trying to do, as opposed to what makes a good picture, what makes an attractive diagram. And that's tough.
I have something I just wanted to add briefly, and that's following on that and answering Carol better. As I think about all this, we've gotten in the trees a little bit. What I do say to the public, and I think is important when I'm lecturing about human evolution, there's a lot you agree on and a lot you've discovered in the last 20 years. We're closing in on the time and place where ancestors arose. It's Africa. Everything over 2 million years is Africa. We know hominins were out 1.8 million years ago. You know that upright walking came before the big brain and then tool use. We also know that Homo wasn't the only tool maker. There's a lot that has been learned that you agree on, and that this is how science works. You're testing hypotheses about a lot of small details about who's related to whom. These are important questions, but a lot of the big questions you do agree on, and there's been real gains in knowledge. And I think that's exciting, okay? And I think those are the messages that are very important for the public. But science is debate, and hey, guess what? It's okay in science to change your mind. You'd be a terrible scientist if you didn't, when you see new data, right? You don't fall in love with your stories or your evidence. You challenge it, you test it. So that might be a little bit of an answer to this dilemma, one of them.
Okay, so I just want to let everyone know that we are at 5:15, and I know the discussion is just getting really heated right now. So, yeah, so no, there's actually a lot of questions. Okay, so there's a lot of people who raise their hands. Yeah, so if Polly, you can go, and then after that, we'll go to you, and then we'll see where the time is after that. Yeah? I'm just doing it based on the number of hands.
I don't know if, is the mic on? Yes. Yeah, I think that one of the big missing pieces between Lucy and the men we send to the moon is language. And we haven't mentioned this at all. But for Don to spin the origin myth of Lucy and the origin myth of IHO, for Anne to write her stories, we need language, of course. And we haven't even mentioned this. But I do think that in looking at our phylogeny and the tendencies that we have evolved, we can really see how the capacity to use language took these basic tendencies and let them explode.
When do you think language started?
Well, I mean, for someone who works with fire and stories, I think language was very gradual, but I think around maybe 350,000 years ago, when you begin to find hearths and we know that people gathered socially in the evening, I think it must have taken quite a leap after that.
Thanks, Polly. All right, over there.
Sure. To answer Dr. Thompson, I believe's question earlier of things I'd like to hear, as a layish person, and in agreement with Bernard that this doesn't really relate to my life as I live it today. And I think that evolutionary mismatch is one of the things that's constantly on my mind. So the way that, I don't relate to this is one of the most interesting things that I think can be answered by studying these questions. Because there are problems other than climate change that we face that I think we find ourselves as a modern species dealing with, and wonder if the, shall we call it, discomfort that many people feel is due to things that we've created as human beings in the last 10 years, or 100 years, or 10,000 years, or are they the same kinds of discomforts that existed in the ancient past? So that's one of the things that I'm always listening for in these, and is constantly on my mind.
Over there.
Yes. I just want to go back to what Carol and Han said before, saying that we live in a period in which there is much distrust in science, and one of the reasons might be because disagreement among scientists is perceived as something detrimental to science. So we must give to the audience something they can understand. So this diagram here, this picture, which Don, I confess, I'm the one who took the picture yesterday evening, so I'm guilty, Your Honor. But I think that paleoanthropologists are extremely lucky because somehow disagreement in paleoanthropology is well perceived in the general audience. Maybe this has something to do with what Anne said, that this is a creation story. So they are passionate about what's next, how the story ends. So when one new fossil gets discovered, they are excited if it falsifies, for example, previous evidence, previous interpretations. And this disagreement, the disagreement that Don had with his colleagues, even with Tim White, not only with the Leakey family, let's say, well, this is something that was in the end well received by the general public. So, and this is probably an exception in science, but maybe not necessarily. Maybe if you look at, for example, at climate change, when climatologists disagree over something, there are some haters out there ready to say, you see, the climatologists disagree, so the whole climate science is wrong. Maybe because there are very strong economic interests there, so this is a different story. But somehow, paleoanthropology has this privilege that can exploit how disagreement is well received in the population. And this is extremely important because this educates the general audience to disagreement, which is how science proceeds. And so these diagrams, which oversimplify the whole picture, might be detrimental to paleoanthropology itself, given this privileged position that it has, which makes it possible to exploit disagreement to, build trust in science, build great connections with the general audience because they want to know how the story ends. Yeah.
Thank you. All right. Okay, so
just addition to what he just said, and I totally agree. Yeah, we have a lot of disagreements, and we always, how we end up our publications, we always say we need more fossils to better understand whatever, we're explaining. So obviously that's clear that whatever we say at the end of all of our research is not the end. It's an ongoing research that's so dynamic. That's what makes really paleoanthropology interesting.
So I have a question. Seems like in paleoanthropology, basically, we are custodians of a creation myth, right? And we have several competing creation myths in the world that are competing with us right now. If you talk about violence in the Middle East, that's a good example of competing creation myths. So I'm asking those of you who actually can write, for example, how do we train ourselves, or how do we get trained to be better communicators
of our creation myth to the general public, because it's a competition where, quite frankly, I'm not sure winning at the moment.
I've talked too much. I think you would look like you want to answer that. Somebody else.
Yeah, I can jump in. No, this is a tremendously important issue. So Carol raised the problem of what leads mistrust in paleoanthropology, and this is a serious question. And I think part of the answer is that we shouldn't focus on communicating results only, but how those results are reached. So issues that pertain to methods, what the nature of the evidence, the nature of the inferences that are being made. And this is not only to the general public, but also among practitioners themselves. Because sometimes disagreement can be an incredibly source for knowing more if we understand why we're disagreeing about interpreting a specific piece of evidence. So it's important for the general public to understand that paleoanthropology is difficult, is extremely difficult, is not rocket science, as I was talking with Bernard earlier. It's much worse. It's much more complicated than rocket science. And this is what is fascinating about the science of human origins. So trying to explain and to be transparent about issues pertaining to method is of tremendous importance. And an interesting aspect is that no matter the evidential constraints, no matter the paucity of the fossil evidence, we've learned so much. So the science works. So it's worth communicating why it does work.
Thank you very much. Actually, Jeff, do you have a question? And then,
I'd just like to say a few words. We've covered such a range of topics, it's kind of hard to resist saying something. First of all, I think that the issue really gets back to what is science. Now, science to me is a collection of methods for evaluating the credibility of knowledge claims about the past, about the sense of, about our experiential worlds, okay? And I don't think that many people in the American public, or the public in general, define science that way. They want some kind of an internal truth, like you get from the Bible, one might think. In the United States, there are many, many people who are convinced, okay, thanks, that are convinced that science should give us unchanging, permanent truth. Well, of course, that's not true. We all know that's not true. And so the reason there's so much skepticism is people confound the results of science, which are simply the best empirically supported hypothesis at a particular time. They confound the results of science with fundamental truth with a capital T. But so that's one issue, I think, that prevents or stands in the way of public understanding of a lot of evolution. Of course, evolution is directionless. People have a great deal of trouble with that notion. And so it's greeted often in public fora with suspicion. During this discussion, I kept being reminded of something that Stephen Jay Gould once said. He said that we're but a late appearing twig on the enormously arborescent bush of life that were it replanted as seed would never yield anything like us again. And I think that's worth keeping in mind in discussions of human evolution, because we are unique, but in one sense, we're only unique in the sense that any species is unique. They all have a sequence of the multiplication rule in statistics that Kim mentioned. One probability that's very small multiplied by another probability is very small. So it's very unlikely that a species like us would ever arise again. That said, it doesn't mean that we can't try to disentangle the kinds of things that made us the way we are. And I think paleoanthropology has been very good at that. Conveying it to the public, though, is a really tricky business. I've debated creationists, creation scientists, various occasions. And the idea that, for example, death, that we would simply be food for worms after we're dead, okay, is so antithetical to the way many people think that they simply can't accept the likelihood that that there were a long series of human-like creatures. They can't accept that. They can't accept that when we die, we're simply dead. As far as I think many anthropologists think, we're nothing more or less than highly intelligent, technologically sophisticated, socially complex animals. But that's not enough for most of the public. And so there's a lot of opposition in the United States especially to the notion of evolution. So we got a lot of battles to fight before we can get to the point where Anne can portray these complex issues to the public at large. And until people realize that nothing's going to save us except ourselves, we're not going to be able to combat climate change. We're not going to be able to save our asses from the ongoing climatic changes. And Arizona will simply die of the heat.
All right, and I think on that very positive note.
Well, I'm going to bring this session to a close.
Yes.